Hey, it's Horner, and this is Projectile Motion Concept Questions number 41 through number 50. You have a cannonball launched from the ground at an angle of 30 degrees. So let's draw our launch angle here with 30 degrees. And it's launched with the speed of 30 meters per second. The ball will land on the ground with a speed of, so we can draw our speed vector here, our velocity vector, 30 meters per second. So no matter what angle you launch it and whatever the speed is, as long as it lands at the same height, it will land at the exact same speed. So that is the answer to number 41. Let's go on to number 42. Number 42 says, a projectile is launched horizontally, hits the ground in 0.8 seconds. If it had been launched with a much higher speed in the same direction, it would have hit the ground if you neglect Earth's curvature and air resistance in, and then this one is also 0.8 seconds. So even though it's got a higher speed in this direction, so let's say that this is our original speed, and then the second time we do it, we launch it in a much higher speed, so VO2. Doesn't matter as long as the height is the same, you will have the same time to fall because we don't worry about the speed in the x. We only worry about the distance because remember dy is equal to 1/2 gt squared, and this is how we know how long it takes for it to hit the ground. Number 43 says if a projectile is fired horizontally in a vacuum, the projectile maintains its horizontal component of speed mainly here just because it is not affected. So it's not affected by horizontal forces. So there are horizontal forces. So if we look at the forces in the x direction, so we could say the sum of the forces in the x direction is 0, and it's because there are no forces in the x direction. For number 44, it says an object is dropped and falls freely to the ground with an acceleration of g. If it is thrown upward at an angle instead, its acceleration would be, and remember it is the same, it is still negative 10 meters per second squared, or g. Okay, that will never ever change. It's always going to be the same. We also need to say, because it's negative 10, this would be g downward. Oops, D-O-W-N, W-A-R-D, so downward, G downward. Number 45. A baseball is hurled into the air at an angle of 30 degrees above the horizontal and lands on a target that is at the same level. This sounds familiar, where the baseball started. The baseball will also land at the target if it is thrown at an angle of, so we need to think of the other angle. In order to figure out what angle it would also be launched at, that it will come back down and hit the same level, we have to use the 90-degree rule. So we take 90 minus the angle that we started with, and that gives us the other angle that we can launch it at in order for it to go to the exact same position. So all you do is take 90 minus whatever your original angle is, and that will give you the second angle. So this is the first one for that range. This is the second one for that range. And it tells you where that second one, what that second angle is to make that range the same. The range is really just the distance from where you launch it to where it falls and where it hits. For number 46, a cannonball is launched horizontally from a tower. So here's our tower, and it's got windows in it, not very nice windows, and we launch a cannonball and it hits the ground. It says the cannon has a x velocity equal to 60 meters per second. It is in the air for 1 second. They want to know where it will be. We know that Vx equals dx over t. So dx is equal to Vx times t. Our Vx we see is 60. Our t is 1, so it will be 60 meters downrange. So from the base of the building out, if it takes 1 second for it to fall, it would be 60 meters from the edge of that tower. For number 46, it says after a rock that is thrown straight up reaches the top of its path and starting to fall back down, its acceleration is, and we know it's always g, down. or negative 10 meters per second squared if we're using an axis where positive is up and negative is down. So that is number 47. We also know that it is the same the entire time. So it is the same the entire time. Number 48, an airplane flying into a headwind loses ground speed, and an airplane flying with the wind gains ground speed. If an airplane flies at right angles to the wind, then the ground speed is, so here's one that is flying north, okay? We have a wind that is blowing west, so we're going to make it go this way. What do we need to do with the two? Well, we need to add our two components together. So let's go ahead and do that. We're going to make our parallelogram, and then we will draw our resulting arrow. Let's do that in purple. And we notice that this line is longer than the original speed of the airplane. So this is the airplane, this is the wind, and this is the resultant. So the ground speed is higher than it would have been if the plane was just flying all by itself. That's number 48. Higher, or you could just say it's more, one of the two. Number 49, Jose can jump vertically 1 meter from his skateboard when it is at rest, when the skateboard is moving horizontally. So here we've got a skateboard, we've got Jose, and he can jump up 1 meter. Okay, and so he's smiling. If it is moving to the right or to the left, okay, when he jumps up, he can still only jump up 1 meter. So it doesn't matter whether you're moving, so like this one, or if you're sitting still, you will always jump the same height. So the answer here would just be 1 meter. So he could jump no higher. For number 50, this is the last one. Which best approximates the resultant of a pair of 6-unit vectors at right angles to each other? So for this one, I've got a 6-unit vector, and I have another 6-unit vector, and they're at right angles to each other. So I need to figure out what is the resultant. So what I'll do is I'm just going to take this one, put it here. I'm going to move this one to this side, like that. And then I'm going to make this side. So now I have a right triangle. I have 6. I have 6. I want to know what this side of the triangle is, and that will be our unit vector. So we know that r is equal to the square root of 6 squared plus 6 squared. So this is equal to the square root of 36 plus 36. So that would be equal to the square root of let's see, 3 and 3 is 6, so that'd be 72. And so here it would be close to 8. Okay, 6 times 6, 7 times 7 is 49. That's not one of the answers. Your answers to choose from on this one are 0, 6, 8, and 12. 8 times 8 is 64. That's really close to 72. 6 times 6 is 36. That's nowhere near. And 12 times 12 is 144, and that is way too big. So your best number here that you're going to pick when you see the answers, which are right here, is going to have to be 8 because it is the closest. And that is number 41 through number 50 for 2D projectile motion.